Greetings, grade 8s. Moving on to the second half of chapter 7 today. 7.3 and 7.4, we start dealing with probabilities. We're switching gears a little bit from looking at graphs. Okay, so we're going to look at probability of independent events. And in this section, we're going to develop and apply a rule to determine the probability of two separate events. Okay, so here's a game with a spinner and a coin. James spun the pointer on the spinner and he tossed the coin. What's the probability that the pointer lands on red? So basic probability is we look at all the options. Those are our total. So there's 4 sections and 2 of them happen to be red. You could also just think of it as, well, half of this spinner, or 2 sections is exactly half, or putting this fraction in lowest terms, right? So half. Does the spinner, and this is going to be the key to the section really, does the spinner result affect the coin toss? And so what you're doing over here, it does not affect what you're doing over here, which means that the 2 events are independent of one another. They do not affect each other. Okay, so no, this wouldn't affect. And if I was to look at the probability for the coin, heads or tails, there's just 1 out of 2. So the probability of each thing happening, we could calculate separately, and we'll look in this section about what's the probability when we put them together in a situation. So using a tree diagram, so we'll go through this first example and I'll use a tree diagram, and I'll also use a table. I find the tables are a little neater, so we'll get into that in the next example. So this situation, we go to spinner with A, B, C, D, E, F, and then kind of like a coin, but it's just a counter with a red side and a yellow side. And so we can answer each of these questions. What's the probability of landing on F? So if I'm looking on here, what's the probability? Well, I could actually map this out with a tree diagram. I have all of these options, A, B, C, D, E, and F. Those are my options when I spin the spinner. So the probability of landing on F is just simply, well, one of these 6 letters is an F, so it would just be 1 out of 6, or 1/6 chance. If I look at just the counter, what's the probability you can flip it and it lands on red? Well, that's just 1 out of 2. Okay, and then, so what we're going to do is we're going to relate those 2 things and put them together. So what's the probability of landing on F and tossing red? So we're going to do both of these independent events separately and see what the probability is. And so a nice, easy way to do this is to do a tree diagram. So basically what we can get here is a bunch of different options. Basically, I'll map out all of my possibilities here for spinning the spinner and then flipping the counter. So red, yellow. So all these are possibilities. I could get an A and then red. I could get A and yellow, and so on. B and red, B and yellow. So if I count all these at the end, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 options altogether. Okay, landing on red and tossing, landing on F and tossing red. Well, the only one that has that out of all of them is right there. So the probability would be, out of the 12 total possibilities, there's only one where you're landing on F and tossing a red. Okay, we'll get back to this in a minute and we'll look at if we can relate these 3 things together, and maybe you already see that. Okay, in the next example, I'm going to use a table to actually figure this out. So Kelsey and Sydney each have their own deck of cards. They're each going to pull out a card and compare the suits. So you do need to kind of know the suits. Spades, hearts, diamonds, and clubs are kind of the 4 main suits if you're not so familiar with playing cards. So if you know that, we know there's 13 of each actually, king, queen, jack, and then 10 through ace. There's 13, 13, 13, 13, so that adds up to 52 cards. Okay, but it's not really important. As long as I know that they all have the same amount, we can just think of it as there's actually 4 suits. So what's the probability Kelsey turns over a spade? Well, the probability she turns over a spade is just 1 out of 4. For Sydney to pull a heart, it's also 1 out of 4. Okay, and so I'm going to do this instead of with a tree diagram, I'm going to show it with a table. So we could have Kelsey on the one side, Sydney on the other, and I'm just going to map out all of their options: hearts, spades, diamonds, and clubs for both of them. So what this does is, I like the table because it neatly shows all the different combinations. We could have Kelsey with a heart and Sydney with a heart, sorry. We could have heart and spade, we could have hearts and with a diamond, hearts with a club. We could have Kelsey have a spade and Sydney has a heart. We could have spade and spade, we could have spade with diamond, spade with club. We could have diamond with heart, diamond with spade, diamond with diamond, and diamond with club. And we could have clubs with hearts, club with spades, clubs with diamonds, clubs with clubs. Now this nice and neatly, I think a little bit neater than a tree diagram, shows all 16 different combinations. Four options for each, and adds up to 16. So what's the probability that Kelsey has a spade, so that would be one of these four, and Sydney having a heart? Well, there's just that one option. So this is just 1 out of 16. So again, hopefully you're starting to think, how are these two things related? Her getting a spade and the other one getting a heart, how is that related to Kelsey turning over a spade and Sydney turning over a heart? And we're going to find that it's actually a pretty straightforward little shortcut here. Okay, so in each situation above, this is following along in your book. How does the probability of each individual event relate to the probability of the combined events? So we'll just go back and then we'll tackle the rest of this after we find out the rule, which maybe some of you are already figuring that rule out. So if I go back to the original, if the probability of landing on F is 1 out of 6, probability of tossing red is 1 out of 2, the probability of both things happening is 1 out of 12. Can you see what the relationship is? I hope you can. It's really just multiplying those two independent events together, and we learned how to multiply fractions. We multiply the tops, we multiply the bottoms. So 6 and 2 multiply to give you 12. So it's not a coincidence that you're getting that. You can map it out to find out that it does work, but that rule will always work actually. So same thing here. Probability of the one getting a spade, probability of the other one getting a heart, okay, and that adds up, right? When we multiply 4 times 4, we get 16. So that's actually the rule, okay? So write a rule to find the probability of two independent events. It's the probability of event A, so probability A times the probability of B is equal to the probability of A and B happening. Okay, and so further on in probability, we'll actually kind of make the proper notation for that as well. Okay, so then if I have that rule, it's always going to work. We can always use a tree diagram to check, but if we have this situation where we're tossing a head on a coin, we know that the probability of getting a head on a coin is 1 out of 2. Drawing a red tile from a bag that has 2 red and 3 green, which means they would have 5 tiles altogether. So the probability of pulling a red one would be just 2 out of 5. So if I multiply the tops and I multiply the bottoms, I get my probability. With probability, we learned all about how fractions, decimals, percents are related. We could actually write this as a decimal form if we want, or there's a 20% probability. These are all acceptable answers. We typically put the probabilities in lowest terms. Okay, we can do a quick tree diagram, or I'll just do a table just to show that this will also work if you do it the table way. Here's heads and tails, and then we have red, red, green, green, green. You'll see that you could have heads in red, heads in red, heads in green, heads in green, heads in green, tails in red, tails in red, tails in green, tails in green, tails in green. So there's 10 options, right? And which ones have head and a red tile? Well, these are the ones that have head and red. In other words, 2 out of the 10. Okay, so that rule will work, and we can back it up by showing it with a tree diagram or a table. Okay. Under the connect, you can read through this, but it kind of goes through the exact same situation. Spinning the same spinner twice. You've got red, blue, and green as your options. And so if you're spinning it twice, what are all the possible outcomes? And so you could answer whatever type of question it's going to ask you. Landing on red and landing on blue are independent. Use the table to find the probability of landing on red twice. So you could do the table, but we could also do, okay, well, the probability of landing on red is 1 out of 3. you reset the spinner and you do it again, it's also 1 out of 3, well it's just 1 out of 9. You can see that in the table, there's just 1 out of the 9 options where you're landing on red. Okay,